Hey, sixth graders, today we are going to be discussing proportions, and this goes along with the standard RP3A, but you are really going to use it in RP3C and D as well. If you think about RP, those standards, it stands for ratios and proportions, because ratios and proportions go hand in hand. Hopefully you've already watched our videos on ratios so that you have a good understanding of what a ratio is. And today we're going to introduce proportions. So the questions for today that we're going to be answering are: what is a proportion? How do we set up a proportion? And then how do we solve a proportion? Because you're going to be solving proportions in RP3C and RP3D. So the first question says, what is a proportion? Well, a proportion is a mathematical sentence stating that two ratios are equal. So basically, a proportion is two ratios that are equal. Now, remember back from our first few videos, excuse me, a ratio is a comparison of two quantities. A ratio can be written as a fraction, and so we know that fractions can be equivalent if the numerator and denominator can be multiplied or divided by the same factor. So, for example, in this example, it says 2 out of 6 is equal to 6 out of 18. And that's because 2 6 can be multiplied by 3. 2 times 3 gets us to 6. 6 times 3 gets us to 18. Or 6/18 can be divided by 3 to get us down to 2 6. We could come up with other equivalent ratios as well, because 2 6 could be divided by 2 to make 1/3, and we could continue that sequence. So proportions are two ratios that are equal. Okay, the numbers are not going to be the same, but the fractions themselves, the ratios themselves, are equivalent. Now, some helpful tools that we're going to use in setting up the proportion. If you'll remember back to our ratio video, ratios, the order is so critical in ratios, and we know that rates fall under ratios and unit rates. The order for every RP standard is critical, okay? So when we look at that order, we are going to think, okay, what is the part? What is the part? That's going to go in our numerator. And what is the whole? That's going to go in our denominator. Anytime there's a proportion, we're going to set it up part to whole, okay? And then when we are setting up our proportions, we're going to have two ratios, right? And so we're going to write down the words that they give us, okay? Because the unit of measurement that goes on the top and the unit of measurement on the bottom have to continue throughout the entire problem. We're going to write down what they tell us, what is known, and then we're going to write down what is unknown. So in setting up a proportion, those two equal ratios, we're going to write down the words. We're going to identify what is the part. That's the numerator. What is the whole? That's the denominator. Once we write down our words, we're going to replace those words with, okay, what do we know for sure? And then what's the unknown? And then we're going to get into how to solve the proportion. If you do not set up the proportion correctly, you cannot solve the proportion correctly. So that setup is really important. All right, so let's look at our first example. Anthony rode 4 miles on his bicycle in 20 minutes. At this rate, how long will it take him to ride 24 miles? Okay, so we are looking for, we're talking about miles and minutes, okay? So we're going to use the order that they've already given us, okay? And we're going to write down the words part. Miles out of minutes. Now, this is a rate, you may remember, because a ratio that has two different units of measurement is a rate. So this is a rate, okay? It tells us that at this rate, then what will happen? This part is our known. So that's going to come next. And remember, our numerator has to be the same unit of measurement all the way through, and our denominator has to be the same unit of measurement all the way through the problem because of that order, okay? So, how many miles do we know? Well, we know he rode 4 miles, and we know that he did it in 20 minutes. This is what we know, okay? At this rate, how long will it take him to ride 24 miles? Okay, this is the unknown. It's what we're looking for. So what it tells us is I'm going 24 miles, but I'm looking for the minutes. So I'm going to put a variable there. I'm just going to use X. Now, that is how to set up the proportion. So let's go on to this one. Now, I refer to the part where we talk about part over whole. That's going to be important kind of later on when proportions don't tell us the order specifically when we're talking about percent, okay? But I do want you to just kind of know if there's ever a question about the order, you can use part over whole. Now, another thing that you need to notice is because, well, in just a minute we're going to get to that. I'm getting ahead of myself. But we are actually going to be multiplying here, and when you multiply, the order doesn't matter, okay? In your proportions, it doesn't, unless there is a part and a whole, like in this one, miles and minutes are not part and not whole. As long as the unit of measurement is the same across the numerator and then the same across the denominator, it doesn't necessarily matter which one of these goes in the numerator, which is in the denominator, but it cannot be swapped. So once I put miles in the numerator, everything else has to be miles in the numerator. Once I put minutes in the denominator, both denominators have to be minutes. All right, let's look at our example 2 and go with that second question, how to set up a proportion. Lauren drove her car 240 miles on 10 gallons of gas. Okay. This is our known. At this rate, how many gallons will she use on a 1,200 mile trip? This is our unknown. And what we are comparing is miles and gallons, okay? So we're going to set it up. Miles per gallon. Okay, this is our rate. What we know is that she was able to drive 240 miles for every 10 gallons. What we are looking for in our unknown is we're looking for how many gallons, so we're going to put our X here, for every 1,200 miles. Now, remember in your setup, the order has to be the same all the way across. Numerator has to be the same, denominator has to be the same, okay? If there's a question about the order, you put part over whole, okay? In these two situations, that order was not questioned, it gave it to us. Now, let's get on to question 3. Question 3 says, how do we solve a proportion, okay? So a proportion means that the ratios are equal. So I need to say, okay, for every 4 miles, I can go 4 miles in 20 minutes. So how far can I go at 20? How far can I go? How many minutes will it take me to go 24 miles? Because these are equal, I'm going to cross multiply and solve the proportion that way. So I'm going to multiply 4 and x to get 4x. And I'm going to multiply 24 times 20. And these are going to be set equivalent to each other because the proportions are equal ratios. Now, I'm going to type in my calculator, 20 times 24. Of course, you learned how to do that by hand in 5th grade. Now, when you studied equations, you learned that in order to get this variable alone, I'm going to do the inverse or the opposite operation. So right now, 4 and x are being multiplied. I'm going to divide 4 on both sides to get x alone. And 480, again, you should be able to do this in your head or without a calculator, but you can always use your calculator to check. It's going to equal 120, and we were looking for minutes. So the answer to my question is, it will take me, or take her, him, sorry, it will take Anthony 120 minutes to go 24 miles at this same rate. All right, same thing over here. We have set up our problem. How many gallons will she use on a 1,200 mile trip, given that this is my rate? Now I'm going to cross multiply to solve the proportion. So I get 240x, because those are being multiplied, and 1,200 times 10. Now we know from 5th grade, when we are multiplying by a power of 10, we're just going to move that decimal over one place, okay? So now we have 12,000. Now we're going to do the inverse, or the opposite operation, to get the variable alone. So we're going to divide both sides by 240. And I get x is equal to, and we can type this in our calculator just to make sure, 50. So we were looking for gallons, and our answer is 50 gallons. Now, a couple of things. First of all, you want to make sure that your answer is reasonable. For example, if my mileage is increasing, then my minutes should also increase at that rate. And it did in my answer. Also, if you'll notice in this problem, the numerator, the mileage, was greater than the gallons it took to travel that many miles. So my mileage on this proportion, or this ratio, should be higher than my gallons, as it was. Because it is a multiplication problem, you know that you could always plug this back into where your variable is and check and make sure that the fractions or the ratios are in fact equivalent. Okay, and that's how you set up and solve a proportion. Be sure and watch this video before you go to 3C and 3D, because we're going to be solving proportions there. Have a great day.